Chapter 12, Section 12.1, page 361. Gravity. Why do leaves fall on the ground? The answer is gravity. Gravity is a force that acts between any two masses. Gravity is an attractive force, that is, it pulls objects together. Earth's gravitational force exerts a force of attraction on every other object that is near Earth. That includes you. The force of Earth's gravity holds you on the ground. Note that the force of gravity does not require objects to be in contact for it to act on them. Unlike friction, gravity can act over large distances. Earth's gravity acts downward toward the center of the Earth, and that's a key concept. Earth's gravity acts downward toward the center of Earth. Fortunately, an upward force usually balances the downward force of gravity. Gravity pulls down as the ground pushes up. Falling objects. What forces affect the motion of a dollar bill dropped from the top of a tall building? Both gravity and air resistance affect the motion of a falling object. Gravity causes objects to accelerate downward, whereas air resistance acts in the direction opposite to the motion and reduces acceleration. That's a key point. I'll read it again. Gravity causes objects to accelerate downward, whereas air resistance acts in the direction opposite to the motion and reduces acceleration. So there's a picture of a flying squirrel. It kind of looks like a pillow with arms and legs and a tail. And so this picture is showing that air resistance is acting underneath the squirrel as it flies through the air in an upward force, and gravity is a downward force pulling down on the squirrel. So in figure 8, a flying squirrel has jumped from a tree and is falling toward the ground. As you can see, the squirrel has positioned its body parallel to Earth's surface and spread its arms and legs, like I said, a falling pillow. By doing this, the squirrel creates a very large surface area. The large area maximizes the force of air resistance acting to slow the squirrel's downward acceleration. Because of the squirrel's slower downward acceleration, it is able to travel farther through the air than would otherwise be possible. As objects fall to the ground, they accelerate and gain speed. With increasing speed comes increasing air resistance. If an object falls for a long time, the upward force of air resistance becomes equal to the downward force of gravity. At this point, the forces acting on the object are balanced. Acceleration is 0, and the object continues falling at a constant velocity. Terminal velocity is the constant velocity of a falling object when the force of air resistance equals the force of gravity.